Okay, so today we are going to discuss about the programming. So why we need programming? So programming is the tasks which need to be done with the help of computers. So computers knows only the languages of 0 and 1. So the computers understand only the language which is in the form of binary. So binary means zeros and ones. So input system and the user will give the instructions to the computer to perform certain tasks. Tasks may be an addition of two numbers or a multiplication or a division or shifting or like button click events. So for this he need to give the instructions. So instructions are nothing but programs. So these programs are given as an instructions to the computer to perform certain tasks. Okay, so in computers there are different generation of computer. The first generation computer, the first generation computer are made up of vacuum tubes. Vacuum tubes. These are nothing but the glass, bulk glass tubes. And the memory or the secondary memory we are going to use here is magnetic core delays. These are used as a primary memory. So in our fifth generation or the latest generation we have like RAM and ROM. So in the first generation the hardware is used of vacuum tubes and the primary memory is magnetic core delays, and the secondary memory memories are made up of punch cards. These punch cards are used to store the instructions or the inputs from the users. So these are used to for secondary memory to store certain files and certain data of the user. So the primary memory is to allocate the CPU memories and something. So the disadvantages of first generation computers are overheat. Since we are using the vacuum tubes, the tubes got very heat, and these are very bulky, and they have they are not stronger and they are not faster. So here the programming language or the instructions were given in the format of low level language and assembly level language. So low level language means zeros and ones. So the inputs are given as zeros and ones. If you need to add something, you need to give the instruction in the format of zeros and ones. So and the assembly level is like we have some instructions. So these assembly levels are used in microprocessor and microcontrollers, like add AX comma BX. So this add is converted, again it is converted into zeros and ones, and AX and bx. So ax is the first value and bx is the second value. So this data is added and this result is stored in ax. Okay, so this is what we called in assembly language. So this is about the first generation. Second computers are made up of transistors. So this hardware is made up of transistors. So transistors are cheaper and strong and reliable than the vacuum tubes, which is used as a hardware in the first generation computer. So the memory of primary memory is made up of magnetic core. So this is the primary memory of the second generation computer, and the secondary memory is made up of magnetic tapes. Magnetic tapes and magnetic discs. So magnetic discs. So magnetic tapes and magnetic discs. This is a secondary memory which is used to store the user's files and user information, user inputs. So the primary memory is to run some tasks and it is used for CPU allocation. Okay. So this is the secondary memory, second generation computers, primary and secondary memory. So here the coding language is high level language. Okay, so the drawbacks of this are we need to use many transistors. So since we need to use the many transistor, the cost of the computer is going to be higher. So this is why the second generation computer came failed. So the next generation computer is third generation computer. Next generation computer is third generation computer. So this third generation computer, the hardware of the third generation computer is made up of ICs. ICs means integrated chips. So IC. So IC is consist of transistor, resistor and capacitor. So these are all connected in a single IC. IC is an integrated chip. Okay. So this integration made hardware and software separately. So this integration will separate the hardware and software so that user can pay only the software which he wants. So no need of buying all the softwares. So he can buy only the software which he wants. Okay. So this is an greatest advantage of the third generation computer. So the memory, that is primary memory, again it is made up of magnetic core, and the secondary memory is made up of magnetic disk and floppy disk. So this magnetic disk and floppy disk can incorporate more number of data, like the storage of the data will going to be high, or the maximum capacity of the data can be stored in the magnetic disks and floppy disk. Okay. So the next is like the coding language. The coding language of third generation computer are Photon, Basic and Pascal. So with the help of these coding languages, so we are going to give the instructions to the third generation computer to perform certain tasks. Okay, so this is the the characteristics of third generation computer. Okay, the next computers are fourth generation computers. The next is like fourth generation. So in fourth generation computers, the hardwares are made up of semiconductors. The primary memory is made up of semiconductors, and hardwares are also made up of ICs with large number. So large number of ICs are used, integrated chips. To perform certain tasks, we are going to use the large number of ICs. So this will make the system run faster and process the data very quickly and efficiently. So the memory of this is made up of semiconductor, the primary memory. Okay, the secondary memory, same like magnetic tapes and disks. So with the help of more ICs are integrated, now we are going to give the instructions to the computer with the help of C++. So in the fourth generation of computer, the C and C++ were given as an input or the language to integrate with the computer. So to do some tasks, we are going to give the C like the instruction in the form of C and C++. So this is where the C and C++ came into existence, that is in the fourth generation of computer. Okay. So the next is like fifth generation. Fifth generation is the present generation laptops. So these are all made up of ICs with large number, yes, and the memory is semiconductor with magnetic tapes and disks. So here the large and virtual ICs are used in fifth generation computer. So in fifth generation computer, the integrated chips are used with large and virtual ICs, and the memory is like semiconductor, magnetic tapes and disks. So you can use the pen drives as also in secondary memory. So here the coding language is Python, Java, C#. So to deal with high level coding languages, the fifth generation computer came into existence. So here it is very fast, and the memory allocation is it is a reliable and flexible, and we can store more number of data in a memory based on the secondary devices which we are going to use. And the programming languages or the instructions were given in the format of language, that is Python, C# and Java. So these programs were given as an instructions to the computer to perform certain tasks. So this is all about the generation of computers. So how computers were generated, developed. So first, second, third, fourth, fifth. So the present version of computers are all on the base of fifth generation computers. So the next is where we are going to use these computers. So the applications of computer. So the applications of computer, in the first, the computer were used only in the military purpose. So in military, so the messages which were sent by the soldiers, so we need to decode that messages. So for that purpose we were using the computers in the military purpose. So in military, the soldiers will give some messages to their commando, in the form of zeros and ones. So we need to convert that zeros and ones to a proper message. So for that purpose the computers were used on those days. So in military, now the computers were used all over the world. Like for daily routines also we need to use the computer. So in hospital or for medical purpose. So in medical, you need to store the patient data, when he has joined, what are the symptoms and what is the disease he is suffering from. So this can make the store the data. So for this we need to use the computer. So the computer will store the data of each patient. So this is for that we need to use the computers. So in schools, organization, home. So we are going to use the computers to do some tasks, like to do the presentation or the PPT, to do the word, or to do the scanning. So for that all we are going to use the computers. So other applications of computers are to predict the weather forecast, or to in the geology field and the psychology field. And nowadays the computers are very good at artificial intelligence and machine learning. So to build some artificial intelligent systems we need to use the computers only. Okay, these are all about the applications of computers, where the computers were used. Okay. The next concept is architecture of a computer. So how computers were designed and organized. So in computers we have input device, storage and output device. And the main part of computer is CPU. CPU is central processing unit. All process will be done with the help of CPU only. Okay, this is the brain or the heart of a computer. Okay. So user will going to give some instructions to the computer. Instructions may be a program or It may be a button click event or an close event or an open a file event. So this is what you give the instructions. Okay. So next is like the instructions were taken as the input. So for this we need some devices. Okay. So then it will going to store. So next the CPU will do the operation which the instruction has been given. So what instruction the user gave, the computer or the CPU will process that task. Okay. So then it will show the output in output devices. So there are some output devices and input devices and the storage devices. Okay. So the input devices, it may be a mouse or it may be a pointer or it may be a like a scanner. Okay. So these are all the input devices. Okay. It may be a touchpad, joystick. Okay. So these are all the input devices. The output devices are like monitors, printers, and the monitors, printers, and the PPT presentation like the screen. So the output which we are going to show to the end user is called the output device. The storage is like it may be a pen drive or it may be a hard disk or it may be an like integrated chips. Okay. So memory cards. So these are all the storage. Now the storage devices has grown very higher, like we are going to use the cloud storages, AWS. So these are all the storage and input and output devices. Okay. So the next concept is like the algorithms, pseudocodes, and flowchart. So before writing any program, we need to write the flow of a program. That is what we call algorithms, flowcharts, and the pseudocode. So suppose, for example, we need to add two numbers with the help of C program. Okay. First, we need to write the algorithms, so that how the overall process is going to work, we need to write. So algorithms are nothing but an English like statements from step 1 of the program to the end of the program. We need to write it in the English. Okay. So English language, we are going to write the overall flow or the overall agenda of an program. So first is like algorithms. So it is like an English like statements of an particular program or particular task. Okay. So like to write this, we need to follow some steps. Okay. Step 1. Firstly, we need to initialize our variables. So initialize A equals 0, B equals 0, and res, that is to store the result. Okay. So firstly, we need to initialize our variables which we are going to use. Next step, step 2. In step 2, we are going to assign some values to A and B. So these are all the two numbers which we need to add and store it in the result format. Okay. So next is like we need to assign the values to the A and B. Assign value to A and B. So I will assign A equals 10 and B equals 20. So now I will assign A equals 20, 10 and B is equals to 20. So then step 3 is like computation. So now we are going to use some arithmetic operators to add A and B. Okay. Step 3. Add A and B, store it in RES. So we are going to store that result in RES, that is the result. Okay, so now we are adding the A and B and store it in the result. Okay, then in the step 4 we are going to print that RES. So the output will going to be printed. So the final step is like end. So this ends our program. So algorithm is nothing but an English-like statement which will like symbolizes the agenda of a program. Okay, so we need to follow this step by step, like what we need to be do in the step 1, step 2, step 3, like that format should be given correctly. Okay, so in step 1 we are going to initialize our variables. So that is, we are going to use 3 variables here, A and B to store the numbers, and RES is to store the result, addition result. Okay, in step 2 we are going to assign the value to A and B. So we are going to give the values as 10 and 20. So then in step 3 we are going to add, like we are going to compute our task, that is we need to add A and B. So like 10 and 20 will going to be add, and it is stored in the RES, that is the result variable. So 30 will be stored in RES. Then in the step 4 we are going to print that RES. So we need to show the user that this is your output. Okay, then in step 5 we are going to end our program. So this is what you call, like what you do in the algorithms. Okay, so this is about the algorithms. Okay, the next one is flowchart. Flowchart is nothing but an symbolic representation of the task or the program. So we are going to use the symbols to recognize or show the output and the inputs and the overall computation of a program. Okay, so the symbols are this is for input and output. This symbol is used to give the inputs or the outputs. Okay, so the next is like this is for decision making, like if this condition works, go to this step, or if this condition is not going to work, go to this step. So for processing this we are going to use the diamond shape. Okay, decision making. Next is like process. Okay, this is what you call in process. Next is like the flow controls. The arrow marks are used to control the flow. So how the flow is going to be worked. So this represents, the arrow mark represents the flow of a program. So this will represents the input and output, this will represent the decision, and this will represent the process, and this will represent the flow of an program. Okay, so for example, now we are going to do one program, that is if the age of an student is higher than 18, so he can vote. If he is less than 18, he cannot vote. This is the output of an application. So now we are going to write the flow chart for this code. First is like we need to start. For start, we are going to use the process symbol. Start. Next is like we need to take the input from the user, like the age of the student. So after start, we are going to take the input age. We are going to like take the input from the user, that is the age is an input. Okay. Next. Now we are going to check if the age of a student is greater than or lesser than. For this we are going to use the diamond shape for decision making. If age is less than 18. So if the age is less than 18, the output is cannot vote. Else, so if the age is like greater than 18, the output is he can vote. So the next is the overall end of a program. If he cannot vote also, the program should end. If he can vote also, the program should end. So the end will have the two outputs, like maybe an like he can vote or it may cannot vote. Okay na? So this is what we are going to do in flowchart. So flowchart is like we need to start the program and we need to give the input as an age, and then we are going to check if the age is greater than 18 or less than 18. So then like if the age is greater than 18, he can vote. If the age is less than 18, he cannot vote. So this is what you call the flow chart. Okay.